So in this video we're going to go through a brief discussion of indices and why the index laws take the form that they do. So looking at the picture that I've drawn here, you can see that the number at the top is what we refer to as the index, or the power, or the exponent, and it tells us how many times we're going to multiply out the base. So this diagram is important, tells us all the terminology that we need to know. And then this definition is important because it's going to help us to sort of prove some of the index laws that we're going to come across. So the first index law I want to have a look at is, so we have some number a to the power of some index m, we multiply it by the same number a to the power of another index m. So using the definition here, we can write out all of the times that we multiply it. Obviously we don't know exactly how many, it's just n times, but we can write that. So that's the first term. Second term is a multiplied out by n times. So we can basically just write all of these a's as a string, because it doesn't matter the order in which we do the multiplication. So we end up with just a load of a's, but how many a's are there in total? Well, we had m and we had n, so altogether that's m plus n a's. Now using a definition but in reverse, this is equal to a to the m plus n. So that's our first rule. A to the m times a to the n is equal to a to the m plus n. So the second law we're going to look at is somewhat similar, but instead of multiplying, we're going to be dividing. So we can write this as a fraction, and using the definition above to expand out the a's, we're going to have a times a times a times a, m times on the top, a similar thing on the bottom, but this is obviously n times, and you can see this is the same as this expression because the fraction obviously just means division by a to the n. So we're allowed to cancel out some of these a's now. And how many times can we cancel the a's? Well, we've got n on the bottom, so we can cancel it out exactly n times. So that means that overall, if we start with m and we're cancelling out n a's, we're left with m minus n at the end of the whole process. So we have n minus n times multiplied by a, so that's equal to a to the m minus n. So that's the second rule. And interesting here is that using the first rule, we can write this as a to the m times a to the minus n, and then equating terms, equate this term and this term, we see that 1 over a to the n is equal to a to the minus n. So that's an interesting result as well, and that will be important later on. So the next rule is that a to the m to the power of m, so we're raising a to the m, then raising all of that to the power of m, this is equal to a to the m times n. Now why is this? Well, use the old definition again. So we have this to the power of n, and this is occurring n times. So then if we just apply the definition again, but this time to the n index, we have this a times a times a, blah, 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 times a times a times a, blah, 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 and so on. And we're doing this now n times, and then this down here is m times, so all of these are m times. So we're doing it m times, and then we're doing it m times n times. So overall that's a times a times a, and so on. But it's m multiplied by m, sorry, n times. So yeah, what does this tell us? Using the definition again, but backwards, that gives us a to the m times n. And yeah, that's our rule. A to the m to the power of n is equal to a to the m times n. The powers multiply. Final rule. Let's say this time we have two different numbers multiplied together, and now we raise them to the power of some index. So, for the final time, we'll apply the definition, multiplying out a times b this many times, n times. Now again, because we can multiply this out in any order we like, we can separate out the a's, so on. Now there's clearly n a's because we have n a b's, and you have an a in each one of them. And similarly for b, n times. So now we're pretty used to this. This is just a to the n times b to the n. So that's our final rule. ab to the power of n equals a to the n times b to the n. So let's have a look at a couple of questions that will help us practice these rules. The first one, we'll start out pretty simple. Let's say we have x to the 7 multiplied by x to the 4. Now using our first rule, rule A, we can simply say that this is equal to x to the 7 plus 4. And that's a bit of simple addition, we get x to the 11. Okay, let's try another question. How about 18 times x to the 5 divided by 9 times x to the 7? So we're allowed to take the 18 over 9 outside, and then we have x to the 5 minus 7. So again, some pretty simple arithmetic. You get 2 times x to the minus 2. So note that we have this negative index here. So if you remember before, we found out this rule, so we can rewrite this if we want as 2 over x squared. But obviously either way is perfectly valid. Okay, let's try one more question. Let's do 24x plus 12x to the 8 divided by 3x cubed. So in the numerator we're just adding up two terms, so we're allowed to split up the fraction as so. And then we can simply apply our rules again. So 24 divided by 3 is 8, and x divided by x cubed is x to the power of 1. Just remember, x by itself is x to the power 1, and then minus 3 because the 3 is on the bottom. And then the second term, 12 divided by 3 is 4, and we have x to the 8, and then 3 on the bottom, so minus 3. So overall, taking out a factor of 4 if you like, we have 4 times 2 to the minus 2 plus x to the minus 5. And obviously if you multiply out these terms here, then you'll get the expression above. Okay, so that pretty much takes us to the ends of all the revision content. Like I said, I'm going to give you a challenge question to go away with and try yourself. Or at least pause the video to try before I go through the answer. So this final challenge question is going to be xy to the x plus y multiplied by x to the x cubed minus x squared divided by x, that's all in the exponent, and then multiply that by y to the minus 3x minus 1 over y, all to the power of y squared. So this question should test your knowledge of all of the rules. Don't be too daunted, just take it step by step. It's relatively simple once you know the rules. So let's go through the answer. So using rule number 4 for this first term, we know that this is equal to x to the x plus y times y to the x plus y. So obviously you have a bit more of a complicated exponent here, but we can distribute it just the same. For example, if you set n equal to x plus y. Now this next term, what we want to do first is evaluate the exponent. So we can write this as x cubed over x minus x squared over x, because we're allowed to split up the fraction. We'll deal with the rest of that in a second. And then the last term, so if you remember from rule number 3, when you have some number to a power and then all of that to some other power, you multiply the powers. So this becomes, that's the first term, and then the last term is y squared over y. So we can of course simplify this further. Let's write this part out again. Now x cubed over x is the same as x to the 3 minus 1, which is x squared. And similarly for the second term, we have x to the 2 minus 1, which is just x. Now, this first term in the exponent can remain unchanged. The second one is quite simply equal to y, because it's y to the power of 2 divided by y to the power of 1. So now we can just combine similar bases. So for x we have x to the x plus y plus x squared minus x. All we're doing here is adding up the powers using the first rule of exponents. And then for y we have y to the x plus y minus 3xy squared minus y. So we can see here that plus x minus x is 0 and plus y minus y is 0. And we're left with the answer, which is x to the y plus x squared times y to the x minus 3xy squared. And that is the final answer for the challenge question. Before we finish, I'm just going to give a quick summary of what we've learned in this video. So firstly, the first law is a to the m times a to the n equals a to the n plus m. Second one is a to the m divided by a to the n is equal to a to the m minus m. Then we have a to the m to the power of n is equal to a to the m times n. And finally, ab to the power of n is equal to a to the n times b to the n. So I hope this video was helpful to you. Please let me know if there's anything you want me to change or anything you think about this video in the comments, and thank you very much for watching.